Welcome to tonight's video. We're going to finish up the Unit 1 Part 1 notes. So the first question says, write using sigma notation. So remember, when we do sigma notation, we're going to want to find the sum of a certain amount of terms equals, and then the sigma sign. We'll use I equals 1. And then we want to find the rule on how many terms there are. So notice since it's plus 4, plus 6, plus 8, it's going to be a quadratic. So our A matrix, remember, is going to be 1, 1, 1, 4, 2, 1, 9, 3, 1. The X matrix, that is the variables A, B, and C, because our quadratic rule is a sub n equals a n squared plus bn plus c. So the B matrix is our terms. So the first three terms are 2, 6, 12. When you type in your calculator X, when you type in A inverse B, you should get the matrix 1, 1, 0. So that means that the rule is that I squared plus I. Now, as far as what term number 110 is, well, if I say n squared plus n equals 110, and I solve, so I move the 110 over, and I factor, so the factors of negative 110 that add to 1 are 11 and negative 10. So I get n equals negative 11, n equals 10. Negative 11 does not work because there cannot be negative terms, especially if you start with 1, you can't go backwards. So that means 10 has to be here at the top. And so here is the sum of the first 10 terms of that sequence that is in sigma notation. So then the next question says, what is this series, n, when we start with k equals 1 and we go to n of negative 1 to the k power, first if n equals 1, well, if n equals 1, then it's just 1, negative 1 to the first. So basically, it equals negative 1 to the first, which is negative 1. But let's say if n equals 2, so it's negative 1 to the first plus negative 1 squared, and that's going to equal 0. And if n equals 3, so it's negative 1 to the first plus negative 1 squared plus negative 1 to the third, which is negative 1. And if n equals 4, the sum of the 4 terms, sorry, that should be a k right there. The sum of the 4 terms is negative 1 to the first plus negative 1 squared plus negative 1 to the third plus negative 1 to the fourth, and that would be 0. So what can you determine if n is odd? If n is odd, the sum of the term, if n is odd, is 0. If n is even, it's equal to negative. Actually, sorry, it's the other way around. If it's odd, it's equal to negative 1. And if it's 0, it's even. All right, that is number 12. Number 13, if A, B, and C are successive terms of a sequence, can you conclude that A is less than B, which is less than C, or A is greater than B, which is greater than C? And the answer is no. And one example is if A is 1, B is 0, and C is 1. Because in this case, A would not be less than B. And then also, A is greater than B here, but B is not greater than C. So it doesn't work either one of those. There are other examples that you could come up with. So 14, this is an algebraic proof. You want to show that the left-hand side is equal to the right. So think of this in terms of what the sum is equal to. So the sum here is equal to A to the A sub 1 plus B sub 1 squared plus A sub 2 plus B sub 2 squared plus, and then it's going to continue on until you go A sub n plus B sub n squared, because it goes to n. Notice the pluses in the right spot. Then if you FOIL this, it's A sub 1 squared plus 2 A sub 1 B sub 1 plus B sub 1 squared plus A sub 2 squared plus A sub 2 B sub 2 plus B sub 2 squared plus plus A sub n squared plus 2A sub n B sub n plus B sub n squared. All right, so then if you combine like terms, you have A sub 1 squared plus A sub 2 squared plus plus A sub n squared plus 2A sub 1 B sub 1 plus 2A sub 2 B sub 2 plus plus 2A sub n B sub n plus B sub 1 squared plus B sub 2 squared plus all the way to B sub n squared. So if you look here, the only thing you have to do to get this to be the same is to factor out that 2. So I'll just rewrite here. Factor out the 2. So it's A sub 1 B sub 1 plus A sub 2 B sub 2 plus plus A sub n B sub n plus B sub 1 squared plus B sub 2 squared plus B sub plus B sub n squared. Now you can write it, this is the sum as I equals 1 all the way to n of A sub I squared plus 2 times the sum as I equals 1 to n of A sub I B sub I plus, and then you have the sum as I equals 1 to n of B sub I squared. And you have shown that this left-hand side is equal to the right-hand side. All right, that concludes Unit 1, Part 1. Any questions, please feel free to ask. Have a good evening.